Okay, welcome back. This video is going over sections 12.6 and sections 12.7 in our textbook that is for the class that would have taken place on Friday, October 21st. So go ahead and pull out your fill-in-the-blank notes that match these that I gave to you in person the last time that we met for class, or you can print out these notes from the email that I sent out that included the 12.6 to 12.7 fill in the blank notes and the take-home quiz for that material as well. So last video that you should have watched, we went over sections 12.3 to 12.5, and we ended that by talking about the definition of polynomials and adding and subtracting polynomials. Today's class then continues on with the idea of polynomials, but today we're going to be multiplying them in section 12.6 and dividing polynomials in section 12.7. So this will finish up our chapter 12 required material. And next class that we see each other in person, we will review, go over any questions you have, and over the quizzes that you've been working on your own at home. And then the following class on Wednesday when we meet, you will have your exam on chapter 12. So filling in these notes and talking about this material, section 12.6 I said was multiplication, and so we're only going to multiply 2 at a time. I've had some students who try to multiply more than 2 at a time and they end up with errors, so I'm giving you this note just to help reduce the amount of errors. And so we start small and we work our way larger in these notes that we're going to start with multiplying 2 monomials. Remember from last time that monomials are single terms. So filling in these blanks, we are going to multiply the numbers, or you could put coefficients. Numbers are coefficients separately and the variables separately. If the variables are the same that are being multiplied, then remember the rule is to add exponents. So for example A here, your instructions are going to say simplify, and you have to recognize that when you have 2 sets of parentheses with no operation in between them, that is implied multiplication. And so you look to see if there's an operation written, and if there's none throughout the section, then it will be multiplying. So for A, the coefficients are 5 times 4, so that gives us 20. And there's only one variable with x cubed, so we don't have to multiply that to change its exponent. So we have 20x cubed as our answer for A. For B, even though it's not written, there is a negative in front of that x to the fourth, and so there's an implied -1 in front of that x to the fourth. And again, it's not written, but the implied coefficient in front of the x to the fifth is 1. And so those coefficients that we're multiplying are -1 times +1 gives us -1. And then x to the fourth times x to the fifth, we have the same base, so we add those exponents of 4 plus 5. And so this gives us -1 x to the ninth, or you can drop the coefficient of 1 as long as you keep the negative and just say -x to the ninth. Either of those are acceptable. For C, notice this time we have 1, 2, 3 monomials that are being multiplied. So we only want to multiply 2 at a time just to reduce the amount of errors. And so I'm just going to start with the first two, 1/2 x times 16x to the 8th. So 1/2 times 16 is 8. And x times x to the 8th, remember there's an implied exponent of 1 on that x in the first monomial. So 1 plus 8 gives me x to the 9 power for those first two monomials. And they're still being multiplied by 3x to the -2 that I'm pulling down. And now I multiply again. I just multiply these two monomials now. And so for these two, I now have 8 times 3 is 24, and x to the 9 times x to the -2, so that's x to the 9 plus a -2 power. So 24x to the positive 7 power. And that's our answer for C. Okay. So multiplying a monomial and any polynomial. So we're getting just a little bit bigger. We still have one monomial in the mix, but moving into bigger polynomials, we're now going to fill in this next blank that we are going to distribute. Distribute the monomial to multiply by each term within the bigger polynomial. And then we use the above rules, sorry, hitting the camera. Then we use the above rules of multiplying monomials to finish simplifying the problem. Let's get this adjusted, then I'll continue. Okay. So it's pretty much just a distributive law problem. So for the first one, we have 2x squared times this binomial. So we distribute 2x squared times 6x and times minus 3. So if I take the time to write that out, this is 2x squared times 6x plus 2x squared times the minus 3 value. And if you can do this without writing this middle step, that's fine, but you just need your arrows and then your answer. And so this first set of monomials being multiplied is 2 times 6 is 12, and then x to the 2 power times x to the 1 power. 2 plus 1 is x cubed. And then for the second set of monomials, 2 times negative 3 is negative 6, and then there's just x squared that was being multiplied. These are not like terms, so we finish with that answer. It is in descending order, notice, from last section. Also notice that last section, 12.5, when we were adding and subtracting, we had to have like terms to add and subtract, and we did not change the exponent when we added and subtracted variables. Now that we're into multiplying variables, okay, notice that you do not have to have like terms to multiply, and you do change the exponent value when you multiply. Those are key differences between adding and subtracting, and then multiplying and dividing. So for B, we're distributing the fraction 4/5 x into this binomial. So we now have 4/5 x times negative 2x to the 4th plus 4/5 x times positive 6x. This first set of monomials is going to be 4 times negative 2 on top is negative 8 over 5 times the implied 1 is 5 for your answer fraction. And then for the variables, we have x to the 1 power times x to the 4th, so we add those exponents to get x to the 5th. And the second set of monomials is 4 times 6 on top of the fraction is plus 24 over 5 times the implied 1 is 5, so 24/5. And then x to the 1 power times x to the 1 power is 1 plus 1 is x squared. Those are not like terms, so we cannot combine them further since they are now being added, and so that is our answer. For C, even though the monomial is on the right side, that's okay, because I think it's easier to think about distributing the smaller one. And so I'm going to distribute this negative 3x value to each of the 3 terms in the trinomial here in C. So I have negative 3x times 2x squared right here, then minus 3x times negative 4x, and then minus 3x times the last term in the trinomial was 8. So multiplying each of these, this first one I get negative 6x cubed The next one is plus 12x squared. And the last term is minus 24x. Just kind of going through multiplying those monomials a little bit faster. And since now we're down to addition and subtraction, you now have to look at like terms and see that there are no like terms. And so this is your final answer here. Okay, now we're going to use those ideas of multiplying monomials to apply them to some specific special products in multiplication. So a lot of students have generally heard of this first rule. That's what the number 1 is for, the first rule. And this particular rule is only used when multiplying two binomials. Essentially what you're doing is using the distributive law twice to multiply the resulting monomials and then combine like terms. But we've come up with a special term for it to help students remember. And so what this first rule is what's called the FOIL, F-O-I-L, FOIL method. And this is for multiplying two binomials. So remember, that's two terms. So in general, if you have a binomial a plus b times a binomial c plus d, when you multiply and add, you'll end up with AC plus AD plus BC plus BD. And where these four come from is what we're about to fill in over here in the blank in terms of helping remember the FOIL for multiplying. So F stands for, remember to multiply the first terms. So that is A is first in this parentheses times C is first in the second parentheses. So A times C. O stands for multiplying the outer terms. So the outer terms, A is on the outside in the first parentheses, D is on the outside in the second parentheses. So A times D. I stands for multiplying inner terms. In inner terms, B is on the inside in the first parentheses, C is on the inside in the second parentheses. So we end up with B times C. And then L is multiply last terms. And the last terms in each parentheses is B for the first times D for the second. Gives us BD. And then notice you just add them all up to come up with your answer. AC plus AD plus BC plus BD is where this formula comes from. So now we're going to practice using that FOIL method with some examples here. So notice we have a binomial times a binomial, so we're good to use the FOIL method. I usually will use this type of method of showing what I'm multiplying by writing above that for first f, in this case is x times x, and so that represents the f. To really show, to help y'all for the first time here, I will write it out. So that is x times x, and these represent the first terms. Outer is x times 3, so this is plus x times 3 for our outer multiplication. Inner is 2 times x, so plus 2 times x for the inner multiplication. Last is 2 times 3, so plus 2 times 3 for the last multiplication for spelling out that word FOIL. So multiplying x times x gives us x squared, plus x times 3 is 3x, plus 2 times x is 2x, plus 2 times 3 is 6. And now that we're down to addition, you can only combine like terms. So notice that only 3x and 2x are like terms that need to be combined. So we still have x squared, but then 3x plus 2x give us 5x, and then plus 6. No more like terms, and this is in descending order. So x squared plus 5x plus 6 is your answer. For B, again we have two binomials. You do not have to write out these FOIL with the multiplication that I'm pointing at here. That's just kind of what I'm doing to show you the first one with a lot of steps. I'm going to show you now what more people show, what I will expect on a quiz or a test. That to multiply in B, first is 3x times negative 5x. So 3x times negative 5x gives us negative 15x. If you still want to write the letters, that's fine to remind yourself, but that represents the F for first. Outer, 3x times negative 6 is negative 18x. That's your outer, the O. Negative 2 times negative 5x is the inners. So negative 2 times negative 5 is positive 10 and x for the inners. And last, negative 2 times negative 6 gives us positive 12 for the last terms being multiplied. Now you need to combine any like terms. Oh, excuse me. This first term, I don't remember if I said it or not, but I just saw in my paper I didn't write that this was x squared. It should have been 3x times negative 5x gave us negative 15x squared. So make sure you do have that x squared. So looking at this now, we have negative 15x squared minus 18x plus 10x plus 12. And now we have to combine any like terms at the addition and subtraction stage. So the only like terms we have here are the negative 18x and the plus 10x that needs to be combined. So negative 18 plus 10 gives us negative 8. So we have negative 15x squared minus 8x for the two terms we just combined, and then plus 12. And there's no more like terms, so that's our final answer. This last example, again, two binomials. So first, x times x squared is x cubed. Outer, x times 3 is plus 3x. Inner, negative 5 times x squared is minus 5x squared. And last, negative 5 times 3 is minus 15. Now notice in this step there's no like terms to combine. So the only thing I'm going to do here is write this expression in descending order, which means I need to switch the order of the x squared term and the x term. So I'm just going to switch that order and have x cubed minus 5x squared plus 3x minus 15. And that is my answer since there are no more like terms to combine. But this is in descending order compared to the previous step. And again, I will ask you to write things in descending order on quizzes and tests. So that was FOILing. Okay, we'll get to other special products a little bit later for number 2, but I want to do multiplying any two polynomials next. So for filling in this blank, we have for multiplying any two polynomials, distribute each term in the smaller polynomial to each term in the larger polynomial. Multiply the monomials and combine like terms. So these ones tend to get big. Hopefully we have enough room here. So we have a parentheses with 4 terms, so that polynomial, times a binomial, 2 terms. So I think it's easiest to take the 2 terms and just, since it's smaller, and distribute into the larger. But we have to distribute one at a time. And so I'm first going to distribute this x, and that x will go to each of the 4 terms in the larger polynomial. So taking the step to write this out for y'all to see, this will now be x times x cubed plus x times 2x squared plus x times negative 3x plus x times 1. And that's just the first value that was distributed. We still have to distribute the 2, which is the last term in the smaller polynomial. So the 2 also distributes to all 4 of the terms in this larger polynomial. So I have now plus 2 times x cubed plus 2 times 2x squared plus 2 times negative 3x plus 2 times positive 1. Okay, so this is very big, but we're going to now multiply each set of those monomials individually and then combine like terms. So for this first one, x times x cubed, since we're multiplying like bases, we add those exponents. So that's an implied 1 plus 3. So we get x to the 4th. Plus x times 2x squared, there's that implied x to the 1. So this is plus 2x cubed. And then we have for this third one, x to the 1 times negative 3x to the 1. So minus 3x squared when I multiply. Plus x times 1 is just plus x. Plus 2 times x cubed, it's just 2x cubed. Plus 2 times 2x squared is plus 4x squared. Positive 2 times negative 3x is minus 6x. And positive 2 times positive 1 is plus 2. Now we have to combine any like terms. So I'm just going to do it in descending order, and notice that my highest degree is x to the 4th. There's no other x to the 4th powers in here. So I'm just going to bring that x to the 4th down, and it might help to then kind of cross out to yourself so you don't look back and redo it. Now, next is x cubed, and notice I have 2x cubes. So 2x cubed and 2x cubed are like terms. So 2 plus 2 for coefficients is plus 4. And remember, when adding, you do not change that exponent, so we still have x cubed. And we've now taken care of the x cubes. For the x squareds is next. We have minus 3x squared and positive 4x squared. So minus 3 plus 4 gives us plus 1 and x squared. And we've taken care of the x squareds. For the x's, we have 1x right there, and minus 6x right here. So 1 minus 6 gives minus 5x. And we've taken care of the x's. And last, we have this plus 2 that does not have any other like term, but we do have to bring the plus 2 down in the answer. So there's no more like terms to combine. So x to the 4th plus 4x cubed plus 1x squared minus 5x plus 2 is your answer. So long problem. There's one more I'm going to show you here. You may want to try this one on your own before watching me and just see if you can check your answer. That's usually what I have students do in class on these longer ones, just to double check you're getting it right. But to continue on and do this problem, I'm going to distribute the smaller polynomial into the larger polynomial. So I'll distribute 2x first to all of these terms in the larger polynomial. So that gives me 2x times 2x cubed right here, and then plus 2x times negative 3x squared, 2x times negative 3x squared, and then 2x times 2x, and then 2x times negative 1. Now we have to distribute the negative 3, the other term in the smaller polynomial, and it will distribute to each of the terms in the larger polynomial as well. So we have minus 3 times 2x cubed, and then minus 3 times minus 3x squared, then minus 3 times 2x, and last minus 3 times minus 1. Now I'm going to multiply each set of individual monomials. So 2x times 2x cubed gives us 4x to the fourth. 2x times negative 3x squared is minus 6x cubed. 2x times 2x is plus 4x squared. 2x times negative 1 is minus 2x. Negative 3 times 2x cubed is negative 6x cubed. Minus 3 times negative 3x squared is plus 9x squared. Negative 3 times positive 2x is minus 6x. And negative 3 times negative 1 is plus 3. If you had trouble following how I multiplied those, you need to go back and review the multiplying two monomials rules. But now we're at the, notice just addition and subtraction that's left, so you can only add and subtract the like terms. So for 4x to the fourth, notice there's no other x to the fourth powers. So we just bring the 4x to the fourth down, and we've taken care of the x to the fourths. For the x cubes, I have minus 6x cubed and minus 6x cubed. So minus 6 minus 6 gives us minus 12, and we keep the x cubes the same. So we took care of the x cubes. For the x squareds, we have positive 4x squared and 9x squared. So 4 plus 9 gives plus 13x squared. And we took care of the x squareds now. The x's, we have negative 2x and negative 6x. So minus 2 minus 6 gives minus 8x. And we took care of the x's. And then last, notice we only have 3 left. There's no other like term to combine with 3, but you do have to bring that plus 3 down in your answer. So we have 4x to the fourth minus 12x cubed plus 13x squared minus 8x plus 3 as our final answer, because there are no more like terms to combine. Now, continuing on with special products, again, we come up with these formulas in math for special products, since some occur multiple times over and over, that we use the formulas to make them easier. If you like the formulas, you can use them, but I'm not going to require you on a quiz or a test to use a formula. I'm just going to ask you to simplify. And so what I'm going to show you on the first one is the method with the FOIL method, the old method, and then the formula method that I'm about to introduce. And you can pick whichever one's easier for you. And then you can work that on the test, and I will just grade you based on whichever method that you picked. So for these formulas, remember the FOIL method was considered the first special product, so we're on number 2 for the second special product. So the product of the sum and the difference of two terms, if you have a plus b as one binomial times a minus b, but notice they only differ by the signs. The formula answer is a squared minus b squared. If you FOIL that a plus b times a minus b, then the middle two terms end up canceling out and leaving you with that a squared minus b squared answer. That's where the formula comes from. And just to tell you, binomials that notice the a's and b's are the exact same placement, and all they differ by is the middle sign, plus and minus. These are called conjugates. Conjugates. All they differ by is the middle sign. What you have to do is you have to be able to multiply, since that's the implied sign in between the parentheses. So notice x plus 2 times x minus 2, that's just multiplication of two binomials. So if you see this on a quiz or a test and you can't remember the formula, then one method you can always do is the FOIL method. That's the old one. And so if I FOIL this example, we'll do first is x times x is x squared. Outer is x times negative 2, so minus 2x. Inner is 2 times x, so plus 2x. And last is positive 2 times negative 2, so minus 4. Then for the FOIL method, you have to combine these two like terms in the middle. That minus 2x plus 2x, they end up summing to 0. And so what you're left with is x squared minus 4 for your answer if you use the FOIL method. If you do that on a quiz or a test, great, good job, you got it. If you want to use the formula method, which is the formula I just provided here, so I'm going to work the same problem again with the formula. The formula, or excuse me, the original problem was x plus 2 times x minus 2. Notice the x's are the same, the 2's are the same spot, and all they differ by is that middle sign, the plus and the minus. And so the formula said that if you had an a plus b times a minus b, your answer was going to be a squared minus b squared format. So what we have to recognize is that a represents the x in this particular case. They're in the first position of these two binomials. So a is x here. And that b represents 2 in this case. They're in the second positions in these two binomials. Notice we do not include the signs because they are already in the formula. So b is 2 in this case. And so if I plug this x and 2 for the a and b into the formula, then I get a is now x quantity squared minus b is 2 quantity squared. And now x squared is x squared minus that negative drops. 2 squared, 2 times 2 is 4. And so I get x squared minus 4 for our answer. And notice that is exactly the same as what we got through the FOIL method. So it doesn't matter which method that you use, you just have to use the method that you pick correctly. Show all of your work, and box your answer. So for this one, a lot of students do like the formula. So I'm going to show one more with the formula since we've done FOIL already many times in this video. And so if I do part B with the formula, and you prefer the FOIL, just FOIL it on your paper and make sure that our final answers check. And so if I'm looking at formula for this, notice I have 6a to the 5th minus 1 and 6a to the 5th plus 1. So my first term, my a's, are 6a to the 5th. In my b, my second term, after the changing plus or minus, which it doesn't matter that the minus is first as long as the sign is different in the second one in the middle. And so my b is 1 in this case. And so my answer should now be a squared minus b squared. So a in this case is 6a to the 5th, and I'm squaring the whole value for the formula, minus 1 squared for b squared. So recall back to our exponent rules that when you have a product like this inside parentheses that's all squared, that square applies to both the 6. So 6 squared is 36. And then a variable a raised to 2 powers 5 times 5 and 2 means you multiply 5 times 2 and get a to the 10th power. Minus 1 squared, 1 times 1 is still 1. So we get 36a to the 10th power minus 1. And if you FOILed, just double check that that's your answer as well. Okay. The third special product that we're going over are squares of binomials, and there's two types of these, one with a plus in the middle and one with a minus. So looking at the pluses first, if you have a parentheses, a plus b quantity squared, one way we can write this out is if something's squared, you can write it out twice. So the parentheses a plus b times the parentheses a plus b. Then the formula that if you want to use this you would memorize is that this would FOIL and simplify to a squared plus 2ab plus b squared. You can put this in or just remember, but this is not equal to a squared plus b squared. You cannot just distribute the square to each of these because of that plus in the middle. So similarly, the a minus b in parentheses quantity squared, it can be written out as a minus b times a minus b. And then the formula part that you can fill in is that this one will be a squared minus 2ab plus b squared. This is not equal to a squared minus b squared. You again cannot just distribute the 2 to both of the a and b in the beginning problem. Be careful there. That's a very common error. Again, you can FOIL right here to see where these formulas came from. So I'm going to work this first example using both the foiling method and the formula method again. I believe most of my students in the past have preferred the foiling method, so that's actually the one that I will then continue with in this one. If you like the formula, feel free to use it on your quizzes and tests, and also on this video you can use the formula method and then you can check your answer with my answer, because both ways will give you the exact same answer. And so for this first one, if I want to use the FOIL method, if I have this quantity 3x minus 1 all squared, then I should recognize that I can write this as 3x minus 1 times 3x minus 1. Since it's the whole quantity being squared, I write it twice. And now if I write it twice, I'm just going to FOIL these two binomials. That I have first 3x times 3x is 9x squared. Outer 3x times minus 1 is minus 3x. Inner minus 1 times 3x is minus 3x. And last, minus 1 times minus 1 is plus 1. And your last step here is going to be that you combine the like terms of negative 3x and negative 3x. So negative 3 minus 3 gives us minus 6x in the middle, and we bring down that 9x squared and plus 1 on the ends. And that is your answer. Notice if you did the incorrect of just squaring the two values, 3x squared gives us the 9x squared, and 1 squared, 1 times 1 gives us 1, but you would miss this middle term of minus 6x. That's where the error comes in. So be really careful there. Doing this same problem, but with the formula method, means if I'm starting over completely, my original problem was 3x minus 1 quantity squared. Now I'm going to compare this to my original two starting formulas over here and see I had a value with a minus in the middle. Since it has the minus in the middle, I'm going to go to the starting of these two equations, or excuse me, two formulas that also had the minus in the middle, so the bottom one in this particular example. And so this is a minus b quantity squared. I look over and see the formula says the answer should be a squared minus 2ab plus b squared. So I'm going to write that here. Because what you do in this method is now identify what your a and b are, substitute them, and then simplify. So in this one, it's really just identifying the first and the second term in the parentheses. So a, the first term, is 3x in our particular example. It's before the minus. After the minus, the b is 1 in this particular example. So b is 1. And you do not include the negative with the b because it's already accounted for in the formula. So now that we've identified what a and b are, we're going to plug a and b into this formula. That we have a is 3x is being squared minus 2 times a is 3x times b is 1 plus b squared is 1 squared. So for the first one, 3x quantity squared means you square the 3 is 9 and x squared is x squared. And now we have minus 2 times 3x is minus 6x times 1 is minus 6x plus 1 times 1 is 1. So we get 9x squared minus 6x plus 1. Notice that that is exactly the same as what we got through FOILing. They are equivalent. And so again, it doesn't matter which of these two methods you prefer to use, you just have to use your method correctly and show me the work for your methods. So from now on, since most of my students in the past have generally liked the FOIL method, that's what I'm going to finish off B and C with. But again, if you like formula, just make sure that you pick the correct formula and substitute and simplify correctly. So for B, 4x plus 5 squared, this is 4x plus 5 times 4x plus 5. You have to write it out twice to use your FOIL method. And now we're going to FOIL. First, 4x times 4x is 16x squared. Outer, 4x times 5 is plus 20x. Inner, 5 times 4x is plus 20x. And last, 5 times 5 is plus 25. Now you have to combine your like terms, which in this one there is just this middle set of like terms. 20x plus 20x gives us 40x. And then I bring down the 16x squared and add with the 25 on the ends. So your answer is 16x squared plus 40x plus 25. And since we're adding at this point, there's no more like terms. It's in descending order. We cannot do anything else, so this is our answer. See, I had to throw in a fractions one to make sure y'all understood this material with fractions. So I'm going to take a little bit more time to write this one out, just to make sure y'all are okay with fractions. So this is 3 halves minus 4x times 3 halves minus 4x. And now we're going to FOIL that. So I'm going to actually write out this step rather than doing it in my head, just to make sure y'all are okay. That I have first is 3 halves times 3 halves. Outer is 3 halves times minus 4x. So plus 3 halves times minus 4x. And I'm going to go ahead and put that over 1. Inner is minus 4x times 3 halves. So minus 4x over 1 times 3 halves. And last is negative 4x times negative 4x. So that's just writing out the FOIL, and now I'm going to do the multiplication for each of these sets of monomials. So remember, with fraction multiplication, you do not have to have a common denominator. You just have to do top times top over bottom times bottom and reduce. So for the first set, 3 times 3 on top is 9, over 2 times 2 on the bottom is 4. The second set here, I can actually reduce the 2 and the negative 4x. That there's 1, 2, and 2, negative 2x, and negative 4x. So what I'm left with is positive 3 times negative 2x is minus 6x over 1 times 1 is 1, but denominators of 1 you don't have to write. The next term, to reduce again, there's 1, 2 in the bottom, and 2x is left when I take out a 2 from the 4x. So I have minus 2x times 3 on top is minus 6x over 1 times 1 is an implied 1 denominator in the bottom. And then negative 4x times negative 4x is positive 16x squared. Finishing this problem, we will combine our like terms here in the middle. Negative 6x minus 6x gives minus 12x. I'm going to bring down that 9/4 and the plus 16x squared. So our like terms are combined, but just to remind you of descending order, right now this answer is in ascending order, smallest degree to biggest degree. For descending, we're just going to switch the order. That we have biggest degree first is 16x squared minus 12x plus 9/4 for descending order. And that's our final answer for this problem. Leave your fractions in reduced fraction form. And that's the end of section 12.6. A lot of multiplication. Last section is section 12.7, division of polynomials. So we're going to start out small and work our way up to the bigger problems. So dividing a monomial by a monomial, single term by a single term, is at step number 1 you're going to divide the coefficients. Remember, those are the numbers in front of the variables. Step 2, use the quotient rule, which means you will subtract exponents of like bases to simplify the variables. So, applying this to our examples here, your instructions will say simplify. That fraction bar means that you will be dividing. You have to recognize that. So for the numbers, the coefficients, we have 32 divided by 4. The letters, we're going to subtract from the top and have x to the 5 minus 2. Since we have like bases of x and x, we subtract 5 minus 2. So 32 divided by 4 is 8. X to the 5 minus 2 is x cubed. And that's our answer. You do need to show work. Even if you can see that in your head, do not just go to 8x cubed. Give me some sort of work or explanation there. So B, we have negative 56 over 2 for the coefficients. For the letters, remember you only subtract like bases. So we have P to the 5 minus 2, Q to the 7 minus 6, and Z. Z doesn't have any other Z on the bottom to combine with, so it just stays the way it was on top. And now we simplify. Negative 56 divided by 2 is negative 28. Then P cubed, Q to the 1 power, which we can just write as Q, and then Z. None of these letters are like bases any longer, so we leave them now at this stage because there's nothing else we can do to simplify, and they all have positive exponents. Okay, for C, we have negative 24 divided by 6 for the coefficients, negative 24 over 6. For the A's, you need to recognize this A on the bottom, since it's written, has an implied exponent of 1. That causes some trouble sometimes. So this is now A to the 2 minus 1 power, B to the 5 minus 3 power, and C to the 10 minus 4 power. And simplifying that, negative 24 divided by 6 is negative 4. Then we have A to the first power, which is just A, B to the second power, and C to the sixth power when we do that subtraction. And this is our final answer. So that's dividing a monomial by a monomial. And now you're going to take this information and apply each of those division concepts to the bigger problems we're about to do on the next page. So we did one term divided by one term. Now you're going to have a bigger polynomial, so more than one term on top, divided by the monomial one term. So what we're filling in is that you're going to divide each term of the polynomial in the numerator by the monomial in the denominator individually. So, working out example A, simplify, you need to recognize that fraction bar implies that you need to divide. And so what we're going to do is, since it's a polynomial on top with multiple terms and just a single term on the bottom, is this single term gets to apply as a denominator to each of these three terms. That this is now 16p squared divided by 4p minus 32p to the fifth divided by 4p plus 4p to the seventh divided by 4p. that monomial applied to each of them. And now, once you've written it this way, this is just like what we did on the previous page, but you have 3 individual sets of division to perform. So 16 divided by 4, that first one is 4, and p to the 2, we're going to subtract 1 for that bottom p, is just p. Minus 32 divided by 4 gives us minus 8, and p to the 5 minus 1 gets rid of the p on the bottom. So we have p to the 4th for our second term. In our third one, 4 divided by 4 reduces out to just 1. You don't have to write it, but you can as a coefficient. And then for the letters, we will subtract 1 from the 7 in the third term to get rid of the p on the bottom. So we have p to the 6th. None of these are like terms anymore. They cannot be combined. So the only thing left to do is, if you're asked for a descending order, is to put the highest degree first. So p to the 6th, and then go down in descending order. Minus 8p to the 4th, plus 4p for descending order. Now, those of you who say, what work do I have to show? Okay, you do have to show some form of work. Do not go just from this beginning problem to this answer. I need to see some idea of what you're doing behind the scenes. So you can show, like I did, all of the steps like this in the subtraction if you just do the showing 16p squared over 4p minus 32p to the 5th over 4p plus 4p to the 7th over 4p, and then go here. That's fine as well. So I'm going to just start showing kind of the minimal amount that I'll accept. And so this is another way that we can imply division, is by using kind of the old school division symbol, but you need to recognize, since we had a whole parentheses divided by this monomial, that monomial still applies as the denominator to all of these individual terms. And so for b, we now have 25x squared y squared divided by minus 5xy plus 15x squared y divided by negative 5xy minus 35xy squared divided by negative 5xy. And now if you can do the rest of this division in your head, that's okay with me. That I can do 25 divided by negative 5 is negative 5. And I'll be subtracting 2 minus 1 to get x to the 1, and 2 minus 1 to get y to the 1. Then 15 divided by negative 5 is minus 3. X to the 2 minus 1 is just x. And the y's, y divided by y, they match. They reduce exactly to 1. So there's no y's left in that middle term. And then we have negative 35 divided by negative 5 is plus 7. X divided by x matches exactly. They reduce to 1. And then y to the 2 minus 1 is just y. Don't worry about putting answers that have multiple variables in them in descending order. Just leave them in the way that I give them to you. So we'll just leave this as our answer. So C, this binomial is divided by a single monomial. So we have 28x to the 7th divided by 4x cubed plus 32x to the 5th divided by 4x cubed. And now you divide each monomial individually. So 28 divided by 4 is 7. X to the 7 minus 3, we'll get rid of the x cubed on the bottom. So that's x to the 4th. And 32 divided by 4 is positive 8. and then x to the 5 minus 3 gets rid of the x cubed on the bottom, is x squared. So 7x to the 4th plus x squared, 7x to the 4th plus 8x squared is your answer. And that is already in descending order. Okay, D is a common error one that I wanted to show you. If you want to try it beforehand and see if you get the answer right and then compare to what I'm about to show you, that would be great to double check how you're doing. But writing this out, we'll have 2x to the 4th y to the 6th divided by x squared y squared minus 3x cubed y to the 4th divided by x squared y squared plus x squared y squared divided by x squared y squared. And now we have to reduce each of these division of monomial individually. So for the first one, 2 divided by 1 for the coefficient is 2. Then x to the 4 minus 2 gives me x squared. Y to the 6 minus 2 gives y to the 4th power. Next I have negative 3 divided by 1 is minus 3. X to the 3 minus 2 is just x to the 1, or x. Y to the 4 minus 2 is y squared. And this is the part that students mess up on. X squared divided by y, or x squared y squared divided by x squared y squared, I think it's easiest to see it's the exact same value top to bottom. And so anything that's the same value divided by itself always reduces to 1. If you subtract the exponents, x to the 2 minus 2 gives you x to the 0. But remember, anything to the 0 power is 1. So you still have this plus 1 out here. And many students will forget that and just leave that off. That would be incorrect. You have to have this whole value to get the correct answer. Okay, so dividing by monomials, what we just finished up, that's what we're focusing on in the division section 12.7. What I'm going to tell you now is some bigger ones that I want to talk about, which is dividing polynomials then by other polynomials that are bigger than monomials. So I'm going to explain these and go over them. A lot of times students think that they look a bit difficult at first, which they are a little bit different way of thinking about the method we're going to use. Don't freak out. Just try on them. Do your best. Let me know if you have questions when we get back to class. But like I said, the focus was the earlier division of monomials. So this is just a few problems I'm going to use to help you start to look into these methods a little bit more. So notice that in the bottom, if there is a plus or minus between terms in the denominator, in this example there's a minus, that means that there's more than one term. In this one there's 2 terms. And if you have more than one term, you cannot separate these terms in the denominator to divide. You have to keep them together, which means that we cannot use the methods we just did above on this page. What we can do is you can do long division though. So we can do long division. I'm going to give you some steps here, which at first the steps may sound confusing. I want you to then look at the examples and see if they make a little bit more sense after that, hopefully. But for now, just fill in the blanks. So what we do for step number 1 is write the top or first value inside the long division symbol, and you'll use 0 placeholders if necessary for any degree that is missing in descending order. You'll then perform long division keeping like terms lined up for less errors. And once you perform the long division at the end, you will write any remainder. any remainder at the end of the answer divided by the original divisor. In your answer format is whatever the quotient, that's whatever the answer value that you divide and get is, plus, this should probably be written a little bit longer line here, but plus the remainder on top divided by the divisor. Remainder over divisor. Now, before we actually do the long division on the next page, I want to remind you of long division with numbers because we're going to apply those ideas now to variables, but the ideas hold the same. So if I give you something like, let's see, 153 divided by 3. Let's actually do divided by 9. I'll show a little bit more. So 153 divided by 9. We put the value on top, which is 153, inside the long division symbol here. And we divide by 9. This is just a review. So what's on top goes inside, what's on the bottom goes in the little curl here. And then we ask ourselves here, well, how many times, or what can we multiply times 9 to get to 1? And nothing can multiply times 9 and get 1. So we move on and consider 1 and 5 together as 15. And say, what value can we write up top that we can multiply by 9 to get to 15, or as close to 15 as we can? And we say, okay, well, the closest we can do is multiplying by 1. So we write that up top. And then we actually do 1 times 9 is 9, and we write that product here. And now what we do is we always then subtract, which is essentially flipping that sign to a minus, and we subtract. So 15 minus 9 gives us 6. And now we pull down the next value, which in this case is 3. We say, okay, how many times, or what can we write here to multiply times 9 and get 63? We would say 7. 7 times 9, we then multiply, gives us 63. And then we always flip the sign for that one we just multiplied, draw our line, and we subtract, and get 63 minus 63 is 0. So we have no remainder, nothing else we have to divide, and so 153 divided by 9, that answer's up top here, is 17. Now you're probably saying, okay, I get that. That was like many years ago. I understand long division with numbers. Awesome. Now what I need you to do is apply the questions and the ideas and the flipping the signs thing that we just wrote out to the polynomials with variables. And so if we turn the page to the last couple questions here, we're going to do just that with this A and B example. So you're asked to simplify, and your indicated operation is division. What you need to notice is that you're dividing by this whole binomial and that there's a minus here. So this is 2 terms, and for more than one term you have to use long division, at least for the point that we're at in this class. But what you cannot do is go back and break it up like we did a few minutes ago. So when I go to write this out, this will be for part A, for my long division here. I put what's first, in this case, inside. But what I need you to notice here is that when I said in step number 1 you were looking to make sure all the terms were written in descending order, is that you have this highest degree is 2. So we have x squared, we have x, and then we just have a constant number. So what that means is that right here, we have all terms are here. We went from degree 2 to degree 1 to degree 0. 2, 1, 0, there's nothing missing. So you don't have to deal with the 0 placeholders in this example. So we put 7x squared minus 3x minus 4 inside that division, and we divide by the whole value of x minus 1 in the little curl. Now, pay attention to what I'm asking as well as what I'm writing. So we start out above the 7x squared, and we're going to ask based on the first term, which in this case is x. So I need to ask, what value with numbers and letters can I write here that I can multiply times x and get 7x squared? So if it helps, you can think about that there's an implied coefficient of 1 in front of that x. So we say, well, 1 times what number gives us 7? So 1 times 7 is 7. And then x times how many x's give us x squared? Remember that you add exponents when you multiply. So we currently have 1 in our exponent value for this x. And so to get to x squared, we need 1 more. So we need to do 7x times 1x should give us 7x squared. So that's how we pick the 7x above here. Now, just like we did previously, you then multiply this. 7x times 1x gives us 7x squared. But this is where it's a little different. You have multiple terms, so you multiply again by the next term. 7x times negative 1 is minus 7x. Now, just like I subtracted on the previous page, subtraction causes flipping signs. So the little rhyme to help remember is that you flip the signs and draw the line. Flip the signs and draw the line. So at this stage, I flip the signs, make the 7x squared minus. Flipping the second sign just so happens to make it a positive now. Flip my signs and draw my line. And now you combine those like terms. Keeping like terms lined up for neatness helps as well in helping get the right answer. So if you picked correctly, this first set should always reduce to 0. 7x squared minus 7x squared, they cancel exactly. But minus 3x plus 7x gives us a positive 4x. And just like we did before, you now pull down the next value in the long division. So we have 4x minus 4. And now we start again. We say, okay, what value can I write up here? What can I multiply times x and get 4x? So you should be saying, well, 1 times 4 would give me 4. So this is a positive 4. And then x, I don't need to multiply by any other x's to get the 1x. It's already there. So I just need plus 4. Then I have plus 4 times x gives me the 4x. And plus 4 times negative 1 is minus 4. Notice I distributed that again to get that value. And now we flip our signs and draw our line. Flip the signs. So I made the 4x negative now and the negative 4 positive to flip the signs. Draw your line. And combine like terms. So 4x minus 4x is 0. Minus 4 plus 4 also is nice and sums to 0. So there's nothing else to pull down. We had 0, so that means there's no remainder. And for no remainder then, you don't have to worry about writing it with the answer. But just like in long division with numbers, whatever's on top here is your answer. So 7x plus 4 is our answer to part A. last problem. So, part B. Sorry, I'm having camera difficulties here. Okay, got it back. Sorry about that. So, last problem. We're still simplifying, which in this case with the fraction bar means that we are dividing. And notice again that right here in the denominator we have a plus, so we have two terms, which since there's more than one term, we need to use long division. This time, when I go to divide and make my long division symbol here, what I'm putting inside the long division, I'm looking at the top and I see x cubed minus x squared plus 4. So if I look at those terms and their degrees, notice that the degrees I have here, I start with 3, then I go to 2, and then there's no x, so that means that's a degree of 0. So my degrees are 3, 2, and 0. And so notice that of those degrees, if I go in numeric order, 3, 2, I'm actually missing degree 1 before I get to 0. And so the fact that I am missing degree 1 means this is where we are going to use a 0 placeholder. So we're missing degree 1, use the 0 placeholder for this value. So when I write this inside, I want to go in numeric order of the degrees, that I have x cubed, then I have minus x squared. Now for degree 1, I'm going to put 0, so plus 0, x. Just to hold that place, because I'll probably get x's later on down the line, and I want to have a column for them so that they're not squished up with the x squareds or the other values. Because if they're squished up, it's very common to make mistakes. So I have the plus 0x, and then I last have that plus 4. And then I'm dividing by x squared plus 2. So now I'm going to do the same questions we just did earlier. So we ask ourselves, what value times x squared gives me x cubed? Remember, you're trying to add exponents to get bigger when you multiply. So I'm going to say x to the 1 power, or just x, so that I can do x times x squared is x cubed, and x times 2 is 2x. So I'm going to line that up in the x's column, notice. So again, for a 0 placeholder, that means I have 0 x squareds in that particular multiplication. So now, just like I did previously, after multiplying, I'm going to flip all of those signs and draw our line. So flip to be minus x cubed. This is now minus 0x squared and minus 2x. Draw my line, and now I combine like terms. So x cubed minus x cubed sums to 0. Minus x squared minus 0 x squared is just minus x squared. and 0x minus 2x is minus 2x. And notice that's why we wanted that 0 placeholder, was to already have this column in place. And now we bring down the next value, which is plus 4. And we start the process over. So we say, well, what value can I write here that I multiply with positive x squared and get negative x squared? So hopefully by now you're recognizing that the x squareds match, so we just need to multiply something by positive 1 to get negative 1. So we'll pick minus 1. So minus 1 times x squared gives negative x squared. And minus 1 times positive 2 is minus 2. Put it in the appropriate column, which means that we had plus 0x this time. And now we're going to flip our signs and draw our line. So right here, I don't know if I said it or not, but when I did minus 1 times x squared, that should have been minus x squared, and I just didn't write the square. So make sure you have that in your notes. But now I'm going to flip my signs, so the minus x squared becomes positive x squared, plus 0x is now minus 0x, and minus 2 flips to positive 2. And I draw my line. Combine like terms, minus x squared plus x squared sums to 0. Minus 2x minus 0x is minus 2x. And 4 plus 2 is plus 6. And now notice, there's nothing else to bring down, but even if I try to multiply again, there's nothing with positive exponents that I can multiply x squared by, since it's big and it's a 2 exponent, to get to a single exponent. So there's nothing else I can do to keep going, which means that this value right here is a remainder. And for the answer format there, we then want the quotient, remember, with the remainder on top. So I'm going to do plus the remainder on top, minus 2x plus 6, divided by whatever the original divisor was, what you were dividing by. So divided by x squared plus 2. And that's how you write your answer format with a remainder. So the answer for B is x minus 1 plus negative 2x plus 6 all over x squared plus 2. And that is your answer for long division. That finishes up sections 12.6 and 12.7, so that's multiplication and division. Make sure that you have gone over all your notes for sections 12.3 to 12.7 that we did via video, so that you are ready when we get back to class on Monday to ask any questions and to go over any particular problems or topic ideas that you still have questions on. Just to remind you for what's coming up is that this particular video was in place of class for Friday, October 21st. You should also have an attachment that I gave you in person and emailed out to you that had the 12.6 to 12.7 take-home quiz. You now need to complete the 12.6 to 12.7 take-home quiz and have that ready to turn in on Monday. And you can also do your homework on the Connect Math program online as well at this point now. So our next class is going to be on Monday, October 24th. It will be in person, back on campus, not on video. So make sure you are back on campus Monday, October 24th. Bring all of these notes that you've watched and filled in. We will be going over and reviewing Chapter 12, so that was sections 12.1 to 12.7, and preparing for the exam that will take place then on Wednesday, October 26th. So all of your Chapter 12 homework will be due on Wednesday, October 26th when class starts that day, so make sure you're getting that done. Also, for Monday, October 24th, your 12.3 to 12.5 take-home quiz and your 12.6 to 12.7 take-home quiz will both be due at the start of class. So make sure that you have those completed and ready to turn in at the start of class. Again, if you need any help in person, make sure that you go to the math lab on campus in the Fort Walton Beach campus. That is room 702 in building 7, and make sure that you take some time to ask them any questions and get your questions answered that you don't feel that you'll have enough time for in class. But we will have a review day, like I said, on Monday, October 24th. I hope you all have had a good week. I hope you're doing well with Chapter 12, and I look forward to being back in class on Monday, October 24th. I will see you then. Y'all have a good weekend.